On the previous video, we talked about the product law, right? But now on this one, we are going to talk about the second law, which we call the quotient law. Remember on the first video, we did a question and then we ended up here. We were stuck here, right? So to finish this one, to get our answer, we now have to tap into the second law called the quotient law. Now, let's look at this word quotient. I said that when we multiply things in mathematics, for example, 2 times 2, right? The result will be what we call a product, right? Now, again, in mathematics, when we divide things, for example, 2 divided by 2, the result will be what we call a quotient. In other words, I'm saying this second law involves dividing things. Are we together? So the first law was saying when the bases are the same and we are multiplying, we are to do what? To add the exponents. So the second law is instead saying when the bases are the same, yes, but we are dividing. Instead, we are going to subtract the exponents. Therefore, I'm saying law 1 and law 2 are pretty much opposites. Are we together? Let's compare the two. Let's compare the two. The beautiful thing that I like about mathematics is that, like, you'd have this thing and also its opposite, right? So that is why it's easier to remember the laws of mathematics and also to for maths to be easy. That is why I'm always saying that maths is easy, because maths has, like, it has something and its opposite. So it's always easier when you remember the first one to always remember the other one. If you can check the first law, let me say law 1, right? It said, for example, 2 times 2, you're going to have 2 to the exponent 2. It came from by doing what? By adding the exponents, right? Law 2 instead, it is saying if it is 2 divided by 2, you are simply going to do what? To subtract the exponents, which in this case will be 2 to the exponent 0. Because we said what? It was 1 and 1, and then it's going to be 1 minus 1. Right? So law 1 and law 2 are pretty much the opposites, right? So if you have something like 5 to the exponent 3 divide by 5 to the exponent 2, that means you're simply going to say what? You're going to keep your base and then subtract the exponents. For example, we're going to have 3 minus 2, which will give us 5 to the exponent 1, which is just the same as writing in as just a 5. Are we together? Now also, the same also works with variables, right? If you have a variable like, for example, x, right? And then it's x, let's say maybe to the exponent 3, and then divide by x to the exponent 2. We are simply just going to keep the exponent and then subtract, keep the base and do what? Subtract the exponents. In this case, it's going to be 3 minus 2, and then you have what? X to the exponent 1, which is just the same as writing it as x. Are we together? But here's something you also need to know about the division, right? Is that division can be written in many forms. In other textbooks, like for example, if it's something like this, you might find that they write the same thing. Instead of writing this division, they would write something like x to the exponent 3, and then they do something like this, like a long line, right? A long horizontal line, and then x to the exponent 2. It is still the same way, right? In other textbooks, you might find that they write it like x to the exponent 3, and then they say something like forward slash, and then x to the exponent 2. It is still the same thing. Are we together? You just have to understand how it is written and also to be able to recognize that it's still the same thing. That is why I also said that multiplication can sometimes be written with a dot, something like this, or something with a bracket, something like this. Sometimes they can just write it like this. 3 ways of writing multiplication, 3 ways of writing division. Are we together? Now, we talked of the coefficient law, where we're just looking at as numbers. We looked at it as variables. Now, let's introduce also coefficients, right? Now, with coefficients, right? Let's say maybe we have a number like 4x to the exponent, let's say 3, right? And then divide by, right? 2 to the, and then x, let's say to the exponent, maybe 1, right? What you do, look at this. The bases are the same and you're dividing. That means you can apply your law 2, right? In this case, you can apply your law 2 to say 3 minus 1, right? And now let's look at the coefficients. Remember, I said the coefficients are what? Are the numbers multiplying the variable, or those numbers they usually write next to your variables, right? So it means on this one, we can say the 4 divided by 2, since the bases are not the same. We just divide them the normal way, right? Of in this case, we can say 4 divided by 2 is going to give us what? Like 2 goes how many times into 4? It goes 2 times, right? We can write it like this. Or someone might recognize, no, this 4 can be written in an exponential form, to write it as 2 to the exponent what? To the exponent 2. And then now, since the bases are the same, we're going to keep the base and then do what? Subtract the exponents. But remember, I said when you have, for example, on this coefficient, you see it doesn't have an exponent, right? I said when a coefficient or a variable or even a number doesn't have a an exponent, it means its exponent is what? Is 1, right? In this case, we are going to have 2 minus 1, right? When we solve this one, we're going to have 2 to the exponent. 2 minus 1 is just 1, right? And then x, and then 3 minus 1 is just 2. In other words, this answer can be 2x to the exponent 2. Are we following? Are we following? That is great. That is great. Now, I think for those who know, you've seen something that I wrote before, right? Some of you might have recognized it, or maybe even asked yourself what that thing could be. Remember when I was writing 2 to the exponent 0? Remember this thing, right? This uh, I'm I'm still going to show it after I'm done with the laws of exponents, when I'll be doing the identities of exponents. Remember, I said the laws and the identities of exponents are not the same thing, they're different, right? We have 5 laws of exponents and also 4 identities of exponents, right? Just to for some sort of a sneak peek into this, right? You know that usually you would see someone, for example, maybe they're writing 2 over 2, right? Like others, you just see them canceling this, right? They just cancel this. They say that they canceled each other. The cancelling, the whole cancelling actually comes from this law number 2, right? Whereby we can say they're cancelling each other. Things are just cancelling each other. If we can look at it, it is 2 over 2, right? What's the exponent? The exponent is 1. The exponent is 1, right? This can be written as 2. And then we said when the bases are the same and when we're dividing, we do what? According to this law, we subtract the exponents, right? It's going to be 1 minus 1, which will be 2 to the exponent 0. And then 2 to the exponent 0. We're still going to do it. It's actually 1. This, we're still going to explain it in the identities of exponents. Are we together? Now, let me erase this one, and then let's move. Let's move, right? Sometimes, again, you might find that your exponents are actually negative. For example, let's say you have x to the power, let's say 4, and then over x to the power negative 2, right? When the bases are the same and you're dividing, you do what? You subtract the exponents. Equals to, you say x to the exponent 4, and then minus. I'm recommending that whenever you are subtracting, especially when you're subtracting, right? Whatever you are subtracting, right? Put it in brackets. That's what I'm asking. Because a lot of us are making mistakes when it comes to here, right? We forget that we are supposed to have 2 negatives. Instead, someone would just write 1 like this. This is wrong, right? Because you are subtracting this whole thing. That is why I'm recommending that whenever you're subtracting, whatever you're subtracting, whether it's just one thing or it's 2 things or it's longer, put it in brackets. I'm always asking this. Please do not forget this. Put it in brackets. So to be negative 2, like this. Whenever you're subtracting something, please put it in brackets so that you don't make a mistake. I'm begging you on this one. Now, in this case, negative times negative is going to give us positive, right? So this will become x4 plus 2. Are we together? Then this is going to give us x to the exponent 6. Are we together? Now, let's look at another one, right? Here, I was talking about the negative numbers, right? Where you're having an exponent of a negative number, right? Let's say now, for example, it is also possible. It is also possible, again, for your exponents to be fractions. For example, you have something like x to the exponent, let's say 1 over 2, right? Divide by x to the exponent, let's say maybe to the exponent 1 over 4, right? In other words, the bases are the same, right? We keep the base since we are dividing, and then because we are dividing, we are going to do what? Subtract the exponents. So it's going to be 1 over 2 minus. And remember I said whenever you are subtracting, just so that you don't confuse yourself, whatever you're subtracting, put it in brackets, right? Just learn this every time. You will never go wrong. Right? Do not do not do not make this mistake, right? And then you're going to say x and then 1 over 2 and then negative times this 1 over 4 because the sign is not written. When the sign is not written, it means its sign is what? It's positive, right? So in other words, I'm saying negative times positive is going to give us negative, yes, right? And then 1 over 4. How do you do this? Let me do it for you, but I'm still going to teach this after I'm done with my laws of exponents in another series of fractions. I'm still going to teach you how to do fractions, right? In this case, we are subtracting fractions. If we have something like 1 over 2 minus 1 over 4, I can simply just say 2 over 2, and then we're going to have 2 over 4 minus 1 over 4, which is the same as 1 over 4. Right? So in this case, we are going to have x to the exponent 1 over 4. Right? We're still going to do that. Right? That is how you could do it. Right? Now, let's try to solve this. Now that we've learned the quotient law, let's try to solve this. Right? You have 6x to the exponent 1, y to 7, right? Over 6x to the exponent 5, and then y negative 2. Are we together? Remember this one here. This 6 over 6, right? You have a coefficient of 6 in the numerator and a coefficient of 6 in the denominator. A variable x and a variable x, a variable y and a variable y, right? In other words, that the coefficient can divide with the coefficient, the variable x can divide with the variable x, the variable y can divide with the variable y, right? The bases are the same. The exponents are what? Are 1 and 1, right? We are doing this exponentially, right? So it's going to be 6 to the exponent 1 minus 1, right? And then for x, we're going to have 1 minus 5 because it's going to be 1 minus 5. But remember, I always said that you should do what? Always, whenever you're subtracting, put it in what? In brackets. This is good practice for you, right? And then y, then we're going to have what? It's 7 and then minus what? Minus 2. If you can learn that whenever you're subtracting something to put it in brackets, trust me, you'll never go wrong. Right? Equals to. This also, put it in brackets, please. Just for argument's sake. Just so that you don't make a mistake. So 6 and then it's going to be 1, right? Negative times positive is still negative, so negative 1. And then x and then 1. Negative times positive is still negative, right? And then y and then 7. And then negative times negative becomes positive. So this is like this, right? Equals to, this becomes 6 to the exponent 0. This becomes x to the exponent negative 4. And then this becomes y to the exponent 9, right? 6 to the exponent 0 is 1. This will give us 1. And then x to the exponent negative 4. And then y to the exponent 9. This one here we can leave it out to negative 4. And then y 9. The reason why we are leaving it out is because when you say, you can either call this 1a pole. You can say 1a pole, right? Or you can just say an a pole. So whether you say 1a pole or an a pole is still the same thing, right? In other words, it's like saying one variable of x, right? One variable, one something. You can just say something or just one something. It's the same thing as saying one apple or an apple, right? Now, let me try to give you another question, right? This one, that's what I'm saying. Maths looks tough, but it's actually easy, right? Let's say you have 4 to the exponent x plus 2 over 2 to the exponent x minus 1. You can see this question and maybe think, yo, what is this? What is this? But if you can look at this question, it's still about law 2, right? You just have to be able to understand why am I saying it's about law 2. Let's look at this question. Equals to, right? This 4 here, it can still be changed into an exponential form, right? To say 2 to the exponent 2, right? This 4 can still be written as 2 to the exponent 2. But, because you are writing it in this form, right? That exponent there, put it in brackets. X plus 2. Put it in brackets, right? I'm going to explain. Over 2 to the exponent x minus 1, right? Now, here we can distribute, right? You know how to distribute. If you don't, I'm still going to make videos about distributing, the commutative law, and also the associative property, right? So to distribute, this multiply by this, and again this multiply by this, right? And now you're going to have 2 to the exponent 2x, and then plus 4 over 2 to the exponent x minus 1. Where, if you can look at this, the bases are the same, and then you have your exponents, right? So the quotient law still applies. When the bases are the same and you're dividing, you simply do what? Add you subtract your exponents. So in this case, you're going to have 2 to the exponent 2x plus 4. And remember, I said whenever you're subtracting, put that other thing you're subtracting into your brackets. This is the danger. This is the danger of not putting it in brackets. For example, if you don't put it in brackets, then you're going to have something like this. And then only the negative will affect this exponent and not this -1. Then your calculation will be wrong. That's what I'm saying. Always put it in brackets. Put this whole thing in brackets, right? And now, to continue with this, you're going to have 2 and then 2x plus 4, and then negative times negative times positive, you're going to have negative x, and then negative times negative, you're going to have positive 1. And then this will become 2, and then 2x minus x, you're going to get x, and then 4 plus 1, you're going to get 5. That's how you are going to end it, right? In summary, I am saying the first law, which was the product law, and the quotient law are pretty much opposites, right? Let me summarize again. again. Let me summarize again. If you can look at them, it for law one, look at something. For law one, it was a times a, right? If you have your exponent, it's m, and your other exponent is n, right? You would have a m plus n. That was law one, right? For law two, if you have a times m divide by a times n, then you would have a to the exponent m minus 1 minus n, right? Multiplication. Let me show you something interesting. Multiplication seems to be going hand in hand with addition. Division seems to be going hand in hand with subtraction. I'm going to show you something cool about this as we continue. Just for now, just memorize until here, right? Just know until here. But as we are busy continuing, I'm still going to show you the secrets of mathematics to you, for you to just see that mathematics is actually easy. So after this, I'm still going to continue with law 3 and also law 4. So law 1 and law 2 are opposites. I'm also going to show you that law 3 and also law 4 are also opposites. So let me see you in the next video. Bye bye for now.